You know that feeling, right? You're staring at your phone, tapping away, swiping, and just nothing. A completely frozen screen. Well, today, we're going to pull back the curtain and figure out why our apps freeze and what's really going on inside our phones when it happens. Yup, you tap, you swipe, you wait, and it's like the app just decided to take a nap. The screen is totally locked up, completely unresponsive. It's a universal moment of frustration, for sure. But what is actually happening in there? What's going on behind the glass when an app just decides to stop working? Okay, so to get to the bottom of this, we're going to have to play detective. Seriously. Think of it less like a simple glitch and more like a crime scene. And the victim? Your app's performance. And our investigation has already zeroed in on two main culprits. I mean, these are pretty much the usual suspects behind almost every app that slows down to a crawl or just, dies on you. All right, let's meet culprit number one. We're going to call this one the memory hog. And honestly, it's the perfect name because this is basically an app with just terrible manners. It barges into your phone's workspace, makes a huge mess, and then just leaves it there. So the official techie term for this is a memory leak. And here's a good way to think about it. Imagine your phone's memory is like a workshop with a limited number of workbenches. A good app uses a bench for a project, and when it's done, it cleans everything up. A memory leak. That's an app that just leaves all its tools and junk all over the bench, making it unusable for anyone else. And you can really see the difference here. A well-behaved app is like a good citizen in your phone's little city. It tidies up, frees up space for others, and just keeps things running smoothly. But the memory hog? Nope. It just lets the junk pile up, hoarding resources even when it's just sitting in the background doing nothing. Sooner or later, your phone's operating system has to step in and basically act like a janitor. It kicks off this process called garbage collection to forcibly clean up the mess. But here's the catch. That cleanup process isn't free. It actually pauses your app for a split second, and that's what causes those little stutters and freezes you notice. So the key takeaway is, the messier the app, the more the system has to stop everything to clean up, and the slower your whole phone feels. Okay, so that's the memory hog. Now, let's move on to our second suspect, the UI traffic jam. And this one is less about a slow, messy buildup and more about a single, massive bottleneck that brings everything to a screeching halt. You know, it's kind of wild when you stop and think about it. Even the simplest tap on your screen kicks off this incredible journey. That one little touch has to travel from the hardware, through the operating system, all the way to the app. And then the app has to figure out what to do and draw a response back onto the screen. It's like a tiny, super fast relay race happening thousands of times a day. Okay, now imagine that entire relay race has to take place on a tiny one-lane highway. Every single tap, every swipe, every button you press, it all has to get in line and travel down this one single path to get processed. And in the developer world, this one-lane highway has a name. It's called the UI thread, or the main thread. And its job is absolutely critical. It handles all of your input and everything that gets drawn on the screen. Everything. So what happens if some big, slow-moving truck gets onto our one-lane highway? Well, if an app tries to do a really slow task on this main thread, we're talking downloading a huge file or processing a big photo, it completely blocks the road. Everything grinds to a halt. No other taps, no swipes, nothing can get past it. And your phone's operating system? It's not very patient. If that main highway is blocked for too long, and we're often talking just 5 seconds, the OS basically gives up. It just throws its hands in the air and pops up that message we all dread, application not responding. You know the one. It asks if you want to wait or just put the app out of its misery. So there you have it, our two main culprits, the memory hog and the UI traffic jam. But how do developers actually catch these guys in the act and fix the problems? Well, to track down a memory hog, developers have a really cool tool. They can basically take a snapshot, like a photograph of the app's memory at a very specific moment. And that snapshot is called a heap dump. And the process is pretty much what you'd expect. First, they have to make the freeze happen again. Then, right at that moment, they capture the heap dump. And then the real detective work begins. They sift through that snapshot looking for things, objects, that are holding on to way more memory than they're supposed to. Once they find the bloated objects, they can trace them back to the source of the leak in the code, and finally, implement a fix. Okay, so fixing memory leaks is one part of the puzzle. But what about preventing those UI traffic jams from ever happening? Well, this is where modern operating systems are getting really, really smart. So let's just quickly recap the main problem with a traffic jam. Your actions, your taps and swipes, are the most important things happening. They're the VIPs. But they can get stuck in line behind some slow, less important background task, right? The old way of handling this was pretty simple. Every task just waited in the same line. First come, first served. But the smart way, the way modern systems are moving, is to create a special VIP express lane just for important user-facing tasks. And this is basically what that looks like under the hood. You have a smart resource manager that's acting like a super intelligent traffic cop. It can spot the tasks that are absolutely critical for a smooth experience for you. It calls them delay critical, and it shuffles them right into that fast lane, making sure they get all the power they need exactly when they need it. And get this, the results are pretty staggering. We're not talking about a tiny improvement here. This kind of smart resource management can reduce the lag that you actually notice by up to 10 times. That is a huge deal. It's the difference between an app that feels clunky and an app that feels instantly responsive. So I think the big takeaway here is that a smooth app experience isn't just about having the fastest, most powerful chip. It's really about having smart software that understands what's most important at any given moment, which is your interaction, and giving that task top priority. Which kind of leaves us with one last big question. We've seen all these clever tricks that developers and operating systems are using to fight lag. But as our apps and our phones get more and more complex, is a truly perfectly smooth experience even possible? Or are we just stuck in this constant arms race against the next frustrating freeze?